I'm Dr. Mihir Wagh in the Division of Gastroenterology and Hepatology at the University of Florida in Gainesville, Florida. I would like to discuss with you our study that is being published in Gastrointestinal Endoscopy titled Initial Design of a Novel Suction Enteroscope for Endoscopic Locomotion in the Small Bowel. This study is accompanied by a video as well. As you know, the field of deep enteroscopy or deep small bowel enteroscopy has been recently advanced with the development of first double balloon and then single balloon enteroscopes, and more recently with the availability of Spirus over-tube assisted enteroscopy. However, despite all these enteroscopy systems, deep small bowel enteroscopy continues to be challenging, quite cumbersome, time-consuming, and requires significant experience and skill. And even with these different types of enteroscopes, complete or total evaluation of the small bowel is still not possible. We therefore built a novel suction enteroscope in conjunction with the Center for Intelligent Machines and Robotics in the Department of Mechanical Engineering at the University of Florida. This study reports the initial design and feasibility of using suction for endoscopic locomotion in the small intestine using customized suction tips that were retrofitted or fitted to the exterior, to the outside of an endoscope. Initially, ex vivo studies were done in resected porcine intestinal segments, and then in vivo studies were done in live anesthetized animals. Various prototype suction devices were designed and tested. We started initially with a modified suturing device and then subsequently tested other suction tips as well, which included the ABS tip, stainless steel tip, and the aluminum tip. These were all tested in a computerized force test station, which allowed quantitative assessment of suction and force parameters to design the optimal device and to get the optimal conditions to test locomotion. For locomotion studies, two suction devices were attached to the outside of an endoscope, a fixed tip and a movable tip. Suction was first applied to the fixed tip, which anchored the endoscope in the small intestine. The movable tip was then advanced distally and suction was applied to that tip, which was followed by releasing the suction on the fixed tip. The movable tip was then withdrawn or pulled back, and this allowed the small intestine to telescope or pleat on the enteroscope. With sequential suction and release maneuvers like these, the suction enteroscope was able to actually crawl into the small intestine. Our data showed that there was a linear relationship between suction, force, and tip surface area, with the aluminum tips providing the highest force. In vivo studies demonstrated the concept of locomotion using suction and provided proof of concept. With sequential suction and release maneuvers, the endoscope could be advanced in increments of 25 centimeter lengths in the small intestine. Pathological assessment did not show any evidence of significant intestinal trauma or injury. In conclusion, a novel suction enteroscope was designed and tested, and tip design played a crucial role impacting the functionality of this enteroscopy system. We are currently working on refining this prototype to make it slimmer and more flexible to allow translation to human studies. We are looking forward to getting more exciting data with this device, and thank you for your interest in our study. Thank you.